Hi there, in this screencast I'll be showing you how I made this GIF in R using data from Twitter. Now what you're looking at is the position of a boom out in the Pacific Ocean. This boom is a test run that's being run by the Ocean Cleanup, and what it's doing is they're testing how to collect microplastics from the Great Pacific Garbage Patch. What you can see is this is where it started recording its data, or started making its data available publicly anyway, all the way out till here. It looks like it was being towed at this point, then it was floating around for a little while, and then it encountered some structural damage around about there, and then they've towed it to Hawaii, which is where it is right now, undergoing repairs. Alright, so there's quite a few interesting things here that I thought maybe others might find interesting as well. And yeah, so let's just get into it. So this is the Twitter account. There's a section of the boom. There you can see it a little bit more. And what you can see here is that it's every single day it posts a tweet of where it is, and also a picture from on board. These pictures are actually quite nice. Now what made this a little bit more difficult is that it's tweeting its position as a Google Map link. It's not actually capturing its GPS location on the device that's being tweeted. This is it's an automated account that's busy tweeting this, probably from the headquarters in Rotterdam or something. But yeah, so that's what made it a little bit more tricky, is having to extract this longitude and latitude out of the Google Maps URL. In order to get the tweets, I used this Rtweet package, which is a really amazing package for getting Twitter data. It's the easiest I've found so far. I mean, working a little bit with Python and previously, and it was nowhere near as easy as this. And if you haven't worked or created any sort of access tokens, etc. for Twitter, the rtweet.info website has a really great walkthrough here, which I'll link to. Right, so here's my script. I'll be walking you through each of these sections, but just a brief overview. So that's where I load up all the libraries. This is where I get the data. And once I've got the data, basically all of this is to extract the longitude and latitude from that Google Maps URL, and then also just convert it to the right format. And this is where I plot it, and right at the end here, this is where the GIF is created. Before I run through this, just for anyone who's not very familiar with programming, I just want to highlight that I didn't write this from line 1 to line 59, starting at line 1 and then just working it through as you see it here, and going all the way down, and then eventually ending up with this result. It took a lot of moving backwards and forwards through the code, deleting things, adding other things, adding libraries, etc. Just as an example, when I started off, I just started with these 2 libraries, and then as I sort of went through and I saw what else I needed, I added more and more. And of course there was copious amounts of Googling everything, just about every single line almost has been Googled at some stage. Alrighty, so let's get into it. So I'm going to first load up all the packages. Oops, that first one didn't load, my bad. Alrighty, so that's all the packages read. Then we get the Twitter data using this function from Rtweet. It's get timeline, put in the tag or the Twitter handle that I want, and then I've set the number of statuses to retrieve at the maximum of 3,200, although there's only about 340 posts from this account at the moment. But I just thought, well, this bit of code will last me for a long time, so let's download the tweets. And there it's done. 341 observations. So let's just have a look at this. here's what the tweets look like. What was quite important, which I knew I'd need from the beginning, is this created at. So often when you're doing things with Twitter, you often want to have some look at the date, so you'll end up using this variable here, keeping it. This is where I eventually extracted my this isn't where I extracted the position from, but just so you can see, it keeps alternating between the photos and the I'm about your text. This is just sort of an indication. You can see the source was this Microsoft Power Apps and Flow, so they're using some automated system to do this, and that is probably the boom is capturing its GPS data, sending that to their headquarters, and it's their headquarters actually tweeting this out. So there isn't a device on the boom that's actually tweeting this out. So if I keep going out and out and out, here now you'll see this URL's URL. This I mistakenly first thought is where I'd be getting my Twitter data from. So you see, because the field just cut off there with the little dots, 3 dots, it makes you think that there's more, but there isn't actually more information. There's nothing there, you see, nothing at all. This is just like a shorthand or just a truncated version. Must be what it's actually putting in the tweet. If I'll show you here, that's, well, I'm not actually sure. I'm not sure what it is that is, but I spent ages trying to extract the longitude and latitude from here, only to later realize it's just not there at all. So that was quite a long waste of time. This is actually what I ended up using, this URL's expanded URL. So this is where it says maps, google.com maps, and then you've got your longitude and latitude, and this is what I knew I'd need to extract in order to plot it on a map. Now it's actually not as straightforward as that, as we'll see in a moment. But you know, as with most things with analysis, it's never as easy as you first thought it would be. Right, so that's mainly what I was interested in. So back to the script. Now what I was doing here is, once I loaded the script, I also wanted to create a CSV, a timestamp CSV, just so that I know what data it is that I last used to create the visualization. So I just create this time now object, which is getting this current system time, and then formatting the system time in this specific format. So I'll just run that, and there it is. And as you can see, it's a little bit late at night at the moment. Then I'm just creating the file path here that has this paste function, is just pasting together this string and then the time now, which was what I just saved, separated by this little dash. So let's do that. So now I've got my file path that it's going to save as, and then the save as CSV is a function also from the Rtweet package. Of course, I could have used the tidyverse, is it the reader package that also saves CSVs, but I decided just to use this just to see how it worked. Right, so here I'm going to save this. Now onto actually extracting the data that we want to start wrangling. So here I'm just creating this GPS tweets, which is the raw tweets, and then what I first do is select just the created at and the URL's expanded URL fields, which I showed you earlier. So you've got this created at, and then this URL's expanded URL over there. Right. So then I was filtering out anything where there isn't a URL. So that would filter out all these NA rows over here. Here I'm saying filter out, I'm using string detect. So this is where the stringer package from earlier comes in. So it starts detecting strings. So I was looking for anywhere where there isn't this word map. And just looking at it now, I actually didn't need this, because all of these have the word map in it. But actually why I did this in the beginning was I was filtering out a different couldn't remember, it was one of these other columns. Was it maybe this URLs column? I'm not sure, but there was a column that not every single link was an actual map link. It may actually have even been this, maybe some of the early ones. Let's have a look. Yes, there you go. So you can actually see some of the earlier URLs weren't map URLs. So I thought, okay, there's then precedence of this actually happening, and it's probably just a good idea anyway to just make sure it's only anything that's got the word map in it that actually gets filtered. And then arrange it by the created at date. Let's run that. You've got GPS tweets. Now you see it's a slightly more cleaned up. We'll close this one now. Slightly more cleaned up version. So you can see it's got all the different tweets, etc. And it's got just the map locations. Although I see I arranged it from it was 2018, yeah, that it started. Great. Right, so then what I started doing was, in order to extract this is where it starts getting a little bit tricky. It's not expanding now. So in order to extract the longitude and latitude, it's not quite as simple as just extracting the numbers that you see, because there's actually some other numbers running along just after this where it's cutting off at the moment, and that means it just can be quite. Why is this not showing? See, how can I show you? Right, maybe let me just see if I can show you like this. So GPS tweets, and then we want URLs, and just do the head of that. So you see there's these numbers here, but then they've got a second set which looks like it's again just it's the same thing repeated. You've got this 5Z, and also not everything is extracted in the same way. So what I've been doing here is I've got this regex, which I'm not going to go through regular expressions now. It is quite a tricky, I find it very tricky, difficult subject. Many people do, and it involves quite a lot of trial and error. But basically what I've done here is it is extracting the tweets, or extracting these numbers by looking at anything between this place, well, anything after the word place, if I recall, or anything with the word location, because actually these tweets are saved in two different formats, or these URLs. And just to show you, so for example, you see here's this maps place, that sort of pattern, maps place, and then down here you see there's this different type. It's maps and then location, etc, etc. Right, so all the URLs aren't in the same format. Actually, you can see this is where somewhere it changed over from being this maps.google.com to google.com maps place. So what I did here is this basically picks up either one of these patterns and then extracts those numbers. But I'll show you now, it doesn't look as clean as that. So I'm just going to now add this GPS column and just show you what it actually looks like. Alright, so that's done. So let's look here. Now we've got this GPS, and you can see here now it's still a bit of a mess, but it's picked up from the word place, and then it's extracted this number, and so on. Right, so it's extracted and then as you come through we've picked up the location. But now you can see we're getting a little bit closer because we've got the latitude and longitude at least isolated from any other numbers. Now there are better ways of doing this. There's better ways of doing all of this. And what I probably could have done is, what we'll get to later, is extracting the digits here and doing the first group, etc. But I was really struggling with just getting it to work in the first place, and then often how I do it is I just do it in steps rather than trying to do everything all at once in one code. I just kind of pull it through as I think about it. So what I've done here is I've just at least isolated from all those two sets of numbers. Here's at least the first set of numbers. Alright, so yeah, basically what this is saying is extracting all the numbers between the words place and then between this backslash or forward slash. So you see this place and the forward slash, just as an example. Alright, so then the next thing to do is, in order to now separate just the digits from each one, I don't want to separate all the digits because then I'd mash these two together again. You see here on both sides it's all being separated here by this comma. So basically what I did then is I said separate that GPS into lat and long columns and separate where it sees the comma. So let's run that. And now you'll see. So from that GPS, it's created this lat and long columns. Now I actually just noticed now what it does is it separates it, it removes that original GPS column. Okay, that's interesting. I just realized that right now. So that GPS column was removed, and now you see it's separated latitude and longitude. And now I felt a lot more confidence to be able to extract just the digits from each of these, which is what this regex does. So it basically has a look at all of this code, and as I mentioned, I'm not going to go into regex. I mean, I only partially understand this myself. Someone did very kindly give me this bit of code. However, what was happening was there wasn't this question mark, which seems to be suggest optional matching after the digits, right? So you've got all the decimals, so you've got that decimal point. What was happening where there wasn't a decimal, it was putting NA. So I figured out if I just added this question mark, then it would match more digits optionally that may or may not be there. So I will add a link. There wasn't a link actually, it was the R4DS Slack channel that I've very kindly got some help with this regex. Alright, but let's have a look and then you'll see just how the magic of regex. I'll run it. And there you go. Ta-da! So now the latitude and longitude, we're getting somewhere. It's just the digits. However, I can just quickly show you the problem you have is if you've got the GPS tweets. Let's just try the lat. Where are you? Lat. You see it's a character. So this is what these next two lines do. Okay, and you could probably just combine this somehow into just one long string, but just to show you, I just converted them each to numerics. So although it doesn't look any different now, these are actually numbers, which is something you can use to start plotting with. Right, mapping is another area that I don't find that intuitive. I've got a feeling it's because there's multiple different ways of doing mapping in R, and I haven't come across a really good sort of tidy way. So if you do know, just please tell me in the comments below. Every single time I've tried a map, it's never really worked out that well. It's one of those things that I probably have to just sit down and actually properly learn from a good resource rather than messing around. I think it's just one of those things you can't just mess around with. You actually need a bit of decent instruction from somewhere. However, what I did find, I found multiple blog posts, but this one that I've got the link here, and which I'll link to below, it gave me sort of the basics of what I wanted. And that's what this plot here is doing. It's basically creating this world. So it's calling ggplot with this border, fills in the color and the gray. Then what I've done here, these x limits and y limits, is what zooms in on the map. However, as if I just show you here, what it does is it cuts off bits of the map that otherwise would be there. So it's only what exactly fits in this frame that you're creating. So if something overlaps the frame, it gets cut out, which obviously isn't good. I do know you can use the ggmap package, but I saw that you have to sign up for billing even if you want to use the free tier of Google Maps, and I just didn't feel like doing that. for this bit of work. So it probably would be much easier if I just used ggmap, I guess. But anyway, that's where we are. So this basically creates the sort of base map, if we want to call it that. Let's just quickly call it, maybe let's see if it shows. There it is. Alright, so this is the zoomed in version of the map. Then adding to that, I added all my point data from GPS tweets, longitude, latitude, alpha, etc. And then this transition time and shadow mark, this comes from the ggAnimate package, and this is basically showing the data as it's created at, or it's saying along the created at variable. So it's going to look at this created at and then reveal it in that line. And then shadow mark, this basically just says keep the previous previous points that you show. If you don't have this, it's just going to show each point in turn and erase the previous points. What was a little bit interesting, so while it's rendering, I'm just going to talk about this. I actually used transition reveal previously and in some other times that I've used ggAnimate. However, between when I used ggAnimate before and then using it for this project, it had updated and some of the functions etc changed, and some of the way you call some of them depreciated, etc. So just another just something to highlight to anyone who's kind of doing this for the first time is sometimes if things worked in the past and they're not working now and you update it in between, it may have been that things actually changed in between in those updates. But anyway, there you go, that's now rendered. You can see that's pretty cool. I really like it. It's beautiful. Look at that. Well, excellent. I hope you enjoyed that. I mean, I did go through it quite quickly, but just to sort of show you how I went about it and some of the difficulties I had with trying to get the longitude and latitude out of a URL. It's actually not that easy. But yeah, I'm pretty happy with the results. You know, obviously, if my mapping's better, this could look better, but it's really not too bad. Not bad at all. Right, I hope you enjoyed that. Cheers.